Hello, Math 30-2, and welcome to your second lesson with logical reasoning and set theory. So, in this lesson, we're going to focus a lot more on set theory. Now, the lesson before, we looked at and, or, and not, but that didn't seem so mathematical. It is mathematical, and we'll see why as we go in more, but now we're going to look more into our set theory and what it means in some key words and terms. So to start off, what is set theory? What is set notation? Well, a set is a set of things, a set of items. Instead of calling them things and items, we're going to call them elements. Because if I had numbers, a set of numbers, well, I can't say, well, what numbers are here? Give me that number. It gets confusing because, well, how many numbers are there? Or do you want to give me the number? It just gets confusing. So we call them an element. So how many elements there are. Also, it sounds better than saying things, so we're going to call them elements, okay? Because it might be people, so you can't say things if it's people, because there's people and beings and stuff like that. So we just call them elements, right? So from now on, they're just elements. So anything in the set is an element. Those are the things that make up the set. Now, there's many types of talking about the sets. We could list them as all the elements, we could put them in words, or we could use set builder notation, or set notation, okay? We're going to go over all of those here soon. So here we go. Let's skip ahead to classroom example number 1. It says, P is the whole numbers less than or equal to 3. Q is the whole numbers less than 10. List all the elements in each set. Okay, so let's look at P. Set P, we do these fancy brackets, is equal to whole numbers. So that's going to be 0, 1, 2, and 3. Whole numbers less than 3. Now we want Q. Well, that set is going to consist of even whole numbers, 0, 2. Well, now is 0 even? We're going to say this. 0, 2, 4, 6, 8, and less than 10, so it's not including 10. Okay? This one says less than or equal to, so we include 3. Now it says complete the following. The number of elements in P, that's what that's saying, is equal to, how many do we have? 1, 2, 3, 4. Next one's saying number of elements in Q. I have 5. Okay? Now, we're saying, please write P using set builder notation. So P using set builder notation. So it's kind of like domain and range. Set builder notation is very similar to domain and range. So we're going to look at X. So I'm going to say P is equal to X such that X is less than and equal to 3, right? But X is also an element of whole numbers. Okay? So it kind of looks like that. Now the next one says, which of the following is set builder notation that describes Q? So first of all, if I look at this, this is saying everything less than 10. That's including odds. Now looking at this one here, we're looking at E, such that E is equal to 2x. So 2 times E, all right? So it's 2 times E. But E has to be greater than 0, less than 10. Or 2 times x is equal to e. So when we have 0, which is 0, then when it's 1, and it's an element of whole numbers. But then, if I put in x is, let's say 9 in for x, because it says x is already there, that's 2 times 9 is 18. Now 2 times 9 is 18. So that is too big, so that one doesn't quite work. Let's take a look at this next one. And same with if I used 8, that's going to give me 16, 6 is 12. So this one does not quite work, it's too big. This one here doesn't work. This one here doesn't work as well because, well, there's odds in here. Now let's take a look at this one. 4, less than. Well, my biggest number, if we look up there, is 8. What is 2 multiplied by 4? That gives me 8. So this one might work. Let's take a look at this next one here. We have 2x, 5. Well, that will give me 10. And 10 is too big. So that's not in there. So my only answer is C. hopefully you understand that, okay? Because I just put in the number. If I put in 5 for x, 5 times 2 is 10. That doesn't work. If I put in 1 here, or 4 here, we get 8. If I put in 0, because we can have 0, 0 times 2 is 0, 0 times 4, or 2 times, or 4 times 2 is 8, okay? So hopefully you get that. All right, next little bit here, some terminology, okay? They say here, they're just going over this, what is a universal set, subset, and so on and so forth. So now, a universal set is everything, okay? So in the context of problem set theory, there's generally some larger set that we have in mind. So an example would be, if we're looking at the school, the universal set could be all teachers and students, okay? A subset could be teachers. Another subset could be students. Another subset for the school could be grade 12 students. Wow, that's also a subset of another subset. Grade 12 students is a subset of students. Okay, so that's an example of subsets. They belong to the universal set, and they're completely within the universal set. Next is an empty set. It would be containing no elements. An example for that would be, maybe in the school, if it's a high school, do we have any 5-year-olds in there? No, there won't be any high school with 5-year-olds in it. Or a 99-year-olds. Anyone that's 99 years old? No. Or we could say students taking, we'll say Korean, and there's no Korean classes being taught. No, so those are empty sets. Okay? Now a complement set would be everything else. So the complement set to the teachers in the school would be the students, because it's everything else. If we're only looking at universal set as teachers and students would be the complement of the teachers, and the teachers would be the complement of the students. It's everything else that makes up the set. It's also denoted by this. The empty set is denoted by that. If we say subsets, we use this symbol. Okay? And universal set is always denoted with a nice little U. Notice there's that little dash there. That means complement. Okay? So, or it's not in. Everything that's not in. So here we go. Let's take a look at our first example. It says, consider the following. A is natural numbers less than 20 that are divisible by 3. Okay? So natural numbers less than 20 that are divisible by 3. So my first one is going to be, explain why natural numbers, okay, so I'm going to write these out. So I have 3, 6, I'm going to have 9, I'm going to have 12, 15, 18, and that's it. Okay? Natural numbers less than 20 divisible by 5, I'm always writing them out. 5, 10, 15, and less than cannot equal to. So that's it. Now, explain why the set of natural numbers less than 20 is a suitable universal set. Why? Because all of these numbers and all of these numbers are in it. Because set A and set B are in it. And it doesn't go, are in it. Whoops. And it doesnn't go too big. There's an I there. It doesn't go too big. If I said all less than 100, well then we have a whole bunch of numbers that we don't need. Here, there's not many numbers we don't need, but they're all in it. Okay? Everything with subsets are in it. So it says, list the elements for subset A. I already did that up there. So I'm just going to do again. 3, 6, 9, 12, 15, and 18. Now it wants us to list the subsets for A, or for B. That's going to be 5, 10, and 15. Okay? Now it says, what is everything not in A? So everything not in A from the universal set is going to be 0. Oh, natural numbers. There is no 0 natural number, sorry. So we have 1. We have 2. 3 is in there. So we have 4, 5, 7, 8, oh, 9's in there, 10, because 9's right there, so we have to break everything up to 20, excluding those. 10, 11, 13, because 12's in there, 14, 16, 17, 19. Okay? So numbers less than 20. So that is the subset not in A, or the complement of A. Okay? Write the description of the elements of the complement of set B in words. So we want the description. Okay? So that is, remember when we use the word not? We're going to use it again. We're going to use the word not. So, numbers, natural numbers, because we're looking at natural numbers. Numbers less than 20 that are not divisible by 5. That are not, remember we looked at the not, divisible by 5. Okay? So the next one says, set C is natural numbers less than 20, okay, that are multiples of 6. State whether the following are possible. So we are going to write out all of my elements of this set. So C is equal to multiples of 6, so we have 6, 12, 18. That's it. So C, is C a subset of A? Well, yes it is. That is true. Is C not a subset of B? Well, that is true as well, because not all of C is in B. So that is true. Next thing it says, is everything, is the complement of A a subset of the complement of C? Well, this is also true. Why? Because everything that's not in A is also not in C. But if I went the other way around, everything not in C is not in A, because everything in C is in A. So everything not in A is in C. It's a little bit complicated. If you need me to clarify that, I can clear it up tomorrow. Okay, last question here. It says, consider the sets A, B, C, D from example 2, natural numbers less than 20. So here we go. We have each of them set up. So list the elements and the following sets describing each word. So when we use this here means and. So which ones are in A and B? So A and B, we have 15. And that is it. Okay? So that's that one. And the next one says A or B. This symbol here represents or. Okay, so which elements are in A or B? List them out. So that's going to be A or B. That is, we have to look at this. So we have 3, 6, 9, 12, 15, 18. And then we also have 5 and 10. We don't write anything twice. Next one says not in A, but is in B. Not in A and in B. Okay. So for that one, we need everything not in A and in B. So once again, we want all the ones that are the complement of A, that means not in A, but they must also be in B. So not in A, but are in B. So I take a look at that. Which ones are not in A? Well, not in A is 1, 2. We have 1, 2, 3. There we go. A and B, take a look at this. We have 1, 2, 3. Well, there are 5. Is not in A, but is in B. So there's 5 there. And we have 6, 7, 8, 9. Can't be it. Is 10 in B, but not in A? Yes. And 15 is in both. So we only have 5 and 10. Because it has to be in B, but not in A. Okay? Or not in A, but in B. So that's only between these two out of all three. Because it must be in B, but not in A. That's what it's essentially saying. Now the next one here says, write a set of equivalent to this. So write a set equivalent to B intersects C. So what set is in B and intersects C? I take a look at that. Is in B and intersects C. So C is all of this, but it is in B that intersects C. Well, that's an empty set. There's nothing in there. There's nothing in here that is the same as that. So this here is an empty set. Next one is saying is in A or C. Which ones are in A or C? So I take a look at this. All of C is actually in A. We have 6 there, we have 12, and we have 18. So that is essentially all of set A. Next one is everything in A and C. Well, I look at that, we have 6, 12, and 18 is in set A. So everything in set C is in set A. So if we want and, it has to be in both, that's everything in set C. So that's just C. Okay? Next one. Let's take a look here. It says if D are these numbers, if set D has those elements, okay, list the elements of the following sets. So first we have A and is in the union of B or D. So it could be in B or D, but must also be in A. So here's my A, and we want everything in B or D. That is also in A. Oh, B or D. So there's A, and we have D here, or B. So I'm going to add some numbers there. So we have 5, 10, and 15. So we also have here then 5, 10, and we have 15. So which ones of A overlap? 15. So we have 15. We have 6. So I have 6, 15. What else do we have? 9, 12. Oh, we have 12. And that is, oh, and 18. Okay? So these here are my overlap. Those are the elements that overlap. Let's take a look at number 2. It says, is in A and B or D. So which ones are first in A and B? So A and B. So we take a look at this. A and B is only 15. That's the only one that's in both of these. So we have 15. So I'm going to put that down. We have 15. And or D. So we list all the elements of D. So that's 2, 4, 8, 10, 12, 14, and 18. Okay? Now the last one, it says not in A and not in B. And not in that. So it's the complement of A and B. So the intersection of complement of A and B, and then everything else. So what is not in A and B? Which values are not in A and not in B? Okay, so I have to take a look at this. All right, not in A and not in B. So here, we want all numbers less than 20. So I take a look at this, not in A and not in B, the intersection and everything else. So I'm going to end up getting A, not in B. So everything other than the intersection outside the intersection of that. So we can't have 15. Okay, so everything outside of 15, I believe. Oh, hold on. 1 second here. Okay, so this is pretty much saying everything then, because it's everything not in A and not in B, and everything else that's not in there. So that's everything that's in A or B, really, it just reverses it. So I have 3. I'm going to have 5, 6, 9, 12, 10, 15, 18. So it's everything else. And that is how we do that. So hopefully you understood this. Good luck as I see you tomorrow.